Okay, so this section is quadratic application, so applying quadratics. Our goal for today is I can solve quadratic equations, quadratic equation word problems in vertex form. So they're going to be put in a word problem, and then you have to solve them. So we already know how to solve, so that's a good point. Good part about this. It's that you're going to have to write the equation given a word problem, though. Okay, so it says an object falling on Earth, very important because this has to do with Earth's gravity. It was modeled by the equation. So this is a very important equation that we're not going to just use in this class, but you use in future math classes. H of t equals negative 16t squared plus h, and then this little thing right here is pronounced not. So h naught. So what do those things represent? This is just function notation, which you're aware of. This is like your y value. This is your x value here. So that's an x squared right there. So what does h of t represents? H of t is the current height of the object in feet. So current height in feet. What is t? T is the time in seconds that has passed. And then h naught is the object's initial height. So realize that's just your starting height. But once again, in feet. Okay? So using this equation, you can figure out if you know the initial height from which an object was dropped. And you want to know like what's the height after 1 second, 2 seconds, you can use this equation. Or if you know its height, you can figure out how many seconds has passed. Okay, so here's an example. It says a new roller coaster ride at Six Flags Magic Mountain recently opened in Valencia, California. At the highest point of the ride, Drop of Doom drops thrill seekers from a record-breaking height. Use the formula. H of t equals negative 16t squared plus 400 to determine the height of the coaster at several times during the descent, and use the data to determine how long it takes the coaster to reach the bottom. Complete the table to determine how long it takes Drop of Doom to reach the bottom of its highest drop. Okay, so first we need to figure out after 0 seconds what is the height of the roller coaster. Now what I would do is I would say, oh, the initial height's 400, so it's 400. But if you want to prove it, you could always say, okay, well, I'm going to plug in 0 to the equation. So I'll find h of 0. Negative 16 times 0 squared plus 400. 0 squared is 0. 0 times negative 16 is 0. Plus 400 is 400. So we know that it's going to start off at 400 feet. This gives us the ordered pair. After 0 seconds, it's at 400 feet. All right, now we want to know the height of the roller coaster after 1 second. So now we're going to plug in 1. So we have negative 16 times 1 squared plus 400. So you can use a calculator for it or orders of operations. I'm going to pull up my calculator in case I need it now or in the future here. Okay. All right, so I'm just going to use mental math. 1 squared is 1. 1 times negative 16 is negative 16. Negative 16 plus 400 is 384. So that gives me the point after 1 second the roller coaster is at 384 feet. Now I'm going to do the same thing. So what I'm going to do to make my life easier here is that I'm going to hit copy and then paste. And I'm just going to change this 1 to a 2. Okay, so I can use mental math again if I want, or I can use my calculator. This one I still think is pretty easy here for mental math. 2 squared is 4. 4 times negative 16 is negative 64. Plus 400 is 336 feet. So after 2 seconds, it's at 336 feet. I'm going to paste again and change it to a 3. Okay. All right, so I'll use my calculator for this just to show you that you can use it. Negative 16, oops, gotta get my screen working here. Clear. Negative 16 times 3 squared, and then plus 400. 256. So 256 feet. So after 3 seconds, the roller coaster is at 256 feet. Paste again. Paste. May have to look at this one here. Paste it too. Paste. Delete, 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 delete. Okay. All right, so I have to do 4 seconds and 5 seconds. 4 seconds and 5 seconds. Okay, I'm going to put that in my calculator here. I'm going to go ahead and change this to a 4. Enter, 144. And then I'll change that to a 5. Come on. Whoa, too fast. 5, enter. And it's 0 feet. So after 4 seconds, the roller coaster will be at 144 feet. And after 5 seconds, it'll be at a height of 0 feet. Keep wanting to put feet in my ordered pair. All right, so now what I want to do is I want to plot the ordered pairs on the graph so that you can see that it is part of a downward facing parabola. So I have the point 0, 400, 1, 384, so that's about there. All right. Then I have 2, 336, so this is 350, so like right there. 3, 256, so just above 250. 4, 144, just below 150, and then 5, 0. So notice it's not just these points because it's going to hit all time in between those, and it's going to hit all height in between those. But also what I want you to notice is that this is not linear like chapter 3. This is like a downward facing parabola. So as you can see, it's like a downward facing parabola like this, but we're just looking at like this part of it, right? Okay. All right, so here are follow-up questions. Question 3 here says, what's the height of the coaster before it begins to drop? 400 feet, right? How do we know? We plugged in 0, but we could have also just seen that h naught is equal to 400 in our equation. All right, question number 4. Write and solve an equation that will determine the number of seconds it takes the drop of doom to reach the bottom. Okay, so I already know that the equation is h of t equals negative 16t squared plus 400 because that's what they gave me, right? So I didn't just make that up. Where was it? It's right here. Okay, now if you read this one, it says, I want to determine the number of seconds. So I'm looking to solve for t squared. Okay, and it says when it takes the drop of doom to reach the bottom. So what's the height at the bottom? 0 feet, right? So I want to change the height to 0. And I want to solve that. So now I need to solve for t squared. 3 steps to getting t squared by itself. First step, I have to subtract 400 from both sides. So I have negative 400 equals negative 16t squared. Now I need to divide both sides by negative 16. 400 divided by 16, or negative 400 divided by negative 16, same thing. Negative 400 divided by negative 16, 25. So I have 25 is equal to t squared. And now I'm going to square it to solve. So square root plus or minus, square root plus or minus. I have t is equal to positive or negative 5. Now remember, this is a word problem, so I have to give my answers, I have to relate it to the problem. So it says, how long will it take, write an equation, or how long does it take to get to the bottom, right? So this is our time in seconds. This algebra equation is giving us 2 answers. It's giving 5 seconds and negative 5 seconds. We can't have a time of negative 5 seconds because this is a word problem and time is positive. So my answer is t is 5 seconds. Now I do want to see this and this boxed as your answer. Okay? Once again, the reason why is because we just found this, but realize there's another point over here. We just aren't using that one. Okay. Here's another example. Now it's pretty straightforward from here. Notice you don't need charts or tables to do these. It says Niagara Falls is made up of 3 waterfalls. Let the function h of t equal negative 16t squared plus 174 represent a man falling from the top of the Canadian Horseshoe Falls to the Niagara River below. Let t represent the time in seconds after the man falls, and let h of t represent the height of the man in feet. Question number 1 is, what's the man's starting height? Remember, this is h naught, your initial height, so that's 174 feet. Find how long it will take the man before the man hits the river below. So if he's going to hit the river, his height is 0 feet. Okay? Round your answer to the nearest hundredth, show your work. So I want to know when the height is 0. So I'm going to use my equation, which was provided right here. I'm going to do 0 equals negative 16t squared plus 174. And I need to solve for t squared. So step number 1, subtract 174 from both sides. I have negative 174 is equal to negative 16t squared. I'm going to divide both sides by negative 16. So now I need negative 174 divided by negative 16. Since they're both negative, I can technically leave the negative out. I have 10.875, oops, my 7 disappeared, equals t squared. And now I need to get t by itself, so I'm going to square root plus or minus, square root plus or minus. So I have t equals plus or minus. I need the square root of 10.875, so I'm going to do square root of 10.875. Enter. See what it says to round to, nearest hundredth, 3.30. And then now I'm going to answer the question. So t, when I solve algebraically, is 2 answers, positive 3.30 and negative 3.30. This is a time, so I'm going to put my answer is 3.30 seconds. And that's my answer. Okay, not positive or negative. But I want to see this once again, and I want to see this. Okay. Next one. The second tallest building in the United States is the Willis Tower in Chicago. It's 1,450 feet tall. How long would it take a penny to drop to the ground from the top of the building? So based on the other models that we've seen so far, write a quadratic function for the situation. So I'm going to write h of t equals negative 16t squared plus, and then I need the height of the building, which is 1,450. Solve for the amount of time it would take for the penny to hit the ground. So penny hit the ground, height is 0. So I'm going to do 0 equals negative 16t squared plus 1,450. Show your work algebraically. So I'm going to get t by itself by subtracting 1,450 from both sides. I have negative 1,450 is equal to negative 16t squared. I'm going to divide both sides by negative 16. So I'm going to do negative 1,450 divided by negative 16. I made them both positive because it's going to give me a positive answer. I have 90.625. So a common mistake people do is they'll round this to 2 decimals. You round your final answer 2 decimal places. Square root plus or minus. Square root plus or minus. I have t equals plus or minus, and now I'm going to do square root of 90.625, enter. And I get this very long answer here. So this answer I want rounded to the nearest hundredth. So I'm going to write 9.52. And now I'll give my answers. How long would it take the penny to fall? 9.52 seconds. Okay. Okay. Next it says the gravity on Earth's moon is about 1/6 of that of Earth's. As a result, an object would not be pulled as hard to the moon's surface and would not fall as quickly. An object dropped from 100 feet above the moon's surface, and its equation for the height is given by h of t equals negative 2.66 t squared plus 100. Question A. Given that what we've seen in the other equations, where do we think the negative 2.66 came from? So where did this come from? It was a 16, all right? Well, it says it's 1/6 of that. So if we take 1/16 of negative 16, let's try. 1/16 times negative 16 Oh gosh, that's not what I was supposed to do. 1/6. Let's do that. Let's do that. 1/6 of negative 16 is negative 2.66. It should be negative 2.67 technically, but we'll just say negative 2.66 repeating. Okay, solve for how long it would take for the object to fall to the ground. So falling to the ground would be a height of 0. 0 equals negative 2.66. I missed my point. T squared plus 100. Subtract 100 from both sides. Divide by negative 2.66. So I have negative 100 divided by, negative 100 divided by negative 2.66, enter. And I get this really long number. Do not round it yet. Is it my answer? No, that's what t squared is equal to. So I'm going to write down 37.59398,496 equals t squared. Now I can get t squared by itself by square rooting. So I have t equals plus or minus, and now I need the square root of that. So an easy way to do that is the square root of, and now I want that number typed right here. So if you have a calculator like mine, you can actually jump up to it and hit it, and then it'll pop in there. Or if you don't have a calculator like that, you could hit, if you look down at the bottom of this calculator, I accidentally hit plus. I accidentally hit 8 right there. Right, come on. Right here where it says ANS, answer, the little negative sign. If you use that, it'll transpose the answer into that. So if I go back to this, I'm going to hit clear. Second. And then I want my answer to, notice it's in blue, so I'm going to hit the blue button, which is the second button, a negative sign, and it's going to take the answer and put it in there. So my answer is 6.13 seconds. Okay. Last one, gravity on Mars is about 38% that of Earth's. If an object were dropped 1,000 feet onto a Martian surface, how long would it take to reach the ground? So first off, we have to find that coefficient there on t squared. So I need to take 38% of 16. So 38% of 16 is 6.08. So I know my equation is h of t equals negative 6.08 t squared. And then I need the initial height, which is plus 1,000. Okay, so there's my equation. And now I want to make the height when it will hit the ground. So I'm going to do copy. I'm going to hit paste over here. And then I know that the height will be 0. So I'm going to change the height to 0. And I need to solve this equation. So I'm going to subtract 1,000 from both sides. Negative 1,000 equals negative 6.08 t squared. I'm going to go ahead and divide by negative 6.08. Divide by negative 6.08. So I'm going to do negative 1,000 divided by negative 6.08. And I get, once again, not a beautiful answer. So I'm going to write it down, 164.4736842 equals t squared. Square root plus or minus, square root plus or minus. T equals positive or negative. I'm going to do the square root of that answer, 12.82. So my answer is 12.82 seconds. All right, that's it for quadratic applications. As you can see, if you know the formula, h of t equals negative 16t squared plus h naught, and you know how to solve, it's not that bad of a section at all. All right,